Hey guys, Mr. Mackey here, and welcome to Sequences Week. Brand new week, brand new topic. Now, sequences is basically when you have a series of numbers that could go on forever and ever and ever and ever, but something is happening each time to create the next stage in that series. Today's video, we're just going to go over loads of different types of sequences, what they are, what are the rules for them, and how we can find the next term from those sequences. And then over the rest of the week, I'll be going over 3 different types of sequences used in maths. And then for the week following that, so next week, we'll be focusing on using those sequences in graphs. But that's next week. Let's not worry about then. Let's focus on now. So let me think of a sequence for you. Let's say I have the sequence, 1, 3, 5, 7, 9, 11, and so on. Can you notice something that the sequence has? What is happening? What's the sequence of? Well, yes, they are all odd numbers, so that's a good start. But how is that going to help us figure out what the next one's going to be? What's happening every time? What is going on? From there to there, 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 and what is going on ahead? What is happening? What is going up by 2? Every time. And that will help us find our next term. Because if we know that it's going up by 2, we just add 2 to 11 to get 13. And we can do this forever. 13, 15, 17, 19, 21, 23. Because we know it's going up by 2 each time, we can now continue with it. Let's try a more difficult one. What about this sequence? It's not going up by something each time. When I mean going up, it's not being added each time by the same number, because if we're going up by 1 there, then 2 there, then 4 there, we're not adding the same number. What's actually happening is it's being multiplied by the same number. And in this case, it's being multiplied by 2 each time. Times 2, times 2, times 2, times 2, and times 2. So how can that help us find the next term? Well, you just double 64. So double 64 will get us 128. Double 128 will get us 256. Double 256 will get 512, 1024, and so on. Things like this can help. As long as you know what's happening inside the sequence, you can carry on that sequence for however long you want. I remember when I first taught this in a class, I did one where it was going up by 2 each time, and I asked the kids in the class to tell me how far the sequence could go. I gave them 2 minutes, and whoever got the furthest would win a prize. There was one person in the class who managed to get to the 100 millions in this sequence. It's absolutely insane. And that just shows you that sequences like this can go on forever and ever and ever. You just need to keep going. What about this sequence? Can you notice anything special about this series of numbers? You've definitely seen them before. That's right, they are the square numbers. They're the first 7. 1 times 1 gets us 1, 2 times 2 gets us 4, 3 times 3 gets us 9, 4 times 4 gets us 16, and so on till we get 7 times 7 gets us 49. So now that we know what the rule is, we can find out the next terms in the sequence. So the next terms in this would be 64, because 8 times 8, 81, because 9 times 9, 100, because 10 times 10, 121, because 11 times 11, 144, because 12 times 12, and so on. They're really cool when you look at it like that. You could see, this is also another good example of how we can go on forever and ever and ever. Some questions won't ask you to do that, but as long as you know what's coming next, it's always good to know. There are some sequences out there where finding the next term is obvious, like this one. It's obvious that the next term is going to be 5, then 5, then 5, and so on. But they might ask you what could be the rule, what is happening in this sequence, and there's 3 possible answers you could get for this. The first possible answer is that you're adding 0. It could be. The second possible answer is you're subtracting 0. And the third possible answer is you're multiplying by 1. You could also be dividing by 1. There's 4 actually. I'm a bit of an idiot. But sometimes they might ask you to find the rule, not just the next term. And this gives you 4 different rules. They're all correct. You just need to decide which one's best. So some sequences may need more than 1 rule to make it clear. There's loads out there. One thing I loved doing when I was a teacher was making puzzles like sequences like these to try and tell the kid and try and get the kids to figure out what comes next. And this was a good one. I created this puzzle all by myself and I set them the challenge. Okay, I gave them a week to find out the answer to this sequence. So our question was, what comes next and what's the rule? Now, only one person in the class managed to work this out. And I created this puzzle about 2 years ago. And within those 2 years, only 5 people have ever been able to solve this. A year 7, a year 10, a person in my class at primary, one of the kids in my primary school class in year 5, my father, and a friend of mine who's also a maths teacher. Now, just for a bit of fun, I thought I'd give you a chance at home to figure out the answer to this problem. What are the next 3 terms and what comes next? And this is your challenge. It's just a bit of fun because it helps you understand what sequences are and there can be rules for anything. Now, the one thing I will say is you don't need to know any mathematical knowledge to work this out. You don't need to know how to add, subtract, multiply, divide, fractions, algebra. You don't need to know any of that to work out this answer. I'm really intrigued what some of you are going to say. I want you to find the next 3 terms and why. Good luck. We're going to start a whole new thing about sequences tomorrow. Good luck with this. Let's keep on learning. I cannot wait to see these results. Bring on Sequences Week.